Now, let's talk about what causes changes in pressure. One of the things that causes changes in pressure is temperature. So again, let's make our ground level, and let's make us. And this time, let's talk about a bubble of air. So in this bubble of air is above us. And what we've learned last time is that that bubble of air will put weight on the ground below it. So depending on how many air particles are in that bubble of air, that much air would cause a certain pressure on that surface. If there were less particles, there's less pressure. If there's more particles, there's more pressure. But what causes the number of particles in a particular space to change? So like lots of things, air expands and contracts, meaning gets bigger or smaller depending on the temperature. So if I have a body of air and it has particles in it, then if I heat that air up, it's going to get bigger. And therefore, all those particles are going to spread out just a little bit. So, same number of particles, but now they're spread out. They're less dense. Now that's going to become very important later on. Okay, so if I have a body of air with a certain number of particles and I make it colder, what will happen is that same body of air will shrink. It'll become smaller, it'll contract. And so it'll take up less space, but that means that each one of those particles now has to be more crammed together. So now it becomes denser. That's also going to become more important later on. So why would expanding air and contracting air cause a change in pressure at ground level? Well, here's the thing. If we start off with a body of air and it has 3 air bubbles in it, or 3 air particles in it, let's call that normal. Air doesn't really just have 3 particles in it, but I think you guys get the drift. All right, so if we heat those particles up, they're going to expand, as we demonstrated before. They're going to make a bigger bubble. Now, that means that some of those particles might move out of the area that causes weight. So this original air bubble puts weight. There's 3 air particles that causes weight on this place. But if the air expands, then what ends up happening is those air particles spread out and they get out of the area that actually causes weight. One of them might stay behind, but the other one might move out, which means that instead of having 3 particles cause weight on the area, now there's only 1. So now this place experiencing lower pressure. So what happens when air cools? Well, when air cools, it's going to get smaller, which means it's going to contract. It's going to become more compact. So we're going to take those 3 particles, we're going to move them close together, and we're going to make space for other particles from the atmosphere to move into that area. And so now, instead of 3 particles of air affecting this area, now there's 5, and that 5 particles of pressure causes more pressure down below.